Thank you, Anna. Thank you, Alice. So much valuable information from what Riga Tech Girl does, what's the situation in startup community, women in STEM, and also some opportunities that they mentioned. You know, it's always the first step is really to understand this situation, to assess the numbers, and then we can start to make a change, right? So I'm really glad you really shared this information with us, and I'm really glad we're having these conversations here as well. But when we think about cutting edge technology, we usually think about AI, we think about robotics, but you know, supercomputers, they are also making some breakthroughs in science, medicine, even climate tech. And up next, we have been joined by a woman who works at the heart of it. Someone who knows how crucial high-performance computing is, even if it rarely makes headlines. So please welcome Lina Marta Sarma, senior expert at Riga Technical University High-Performance Computing Center and board member at Riga Tech Girls, as she takes us inside the world of supercomputers and why they matter more than ever.
All right. Hello, everyone. I think there's a lot of R's in all of these sentences, R's in supercomputers and so on and so on. So anyway, today I wanted to talk about a theme close to my heart. And it's throughout, I think, the last 10 years that I've spent in various organizations and generally being close to technology and science, I've always been close to kind of the hardcore science, or more like the niche fields. And I think these niche fields, such as supercomputers, don't get the attention that it should, because it really powers the key components of today's technology, and it really powers the reasons of how we've gotten to the development of AI and the use of AI in the way that we use it today. So today I want to talk about this theme, but before I do my presentation, I really want to do Slido questions. So yeah, I will invite all of you to join this Slido link and indulge me in these questions about supercomputers. The first one should be very, very basic, and should be, what's your associations on hearing this? We will follow this along on our phones, unfortunately, but hopefully that's enough. So you should be able to see other people's answers. So I'm going to follow along as well. Yes. So we don't have to switch in between. All right. All right, so high performance, high tech, super. I was hoping for someone to put in the trooper. Capacity, clever. Yeah, fair enough. Big, Lumi. Ooh, Lumi, nice. Good. There's people who know more. Yes, I found the trooper here. Thank you. Modeling, mega. All right. I think I got a gist of it. So, and then I have a couple of questions for you, because I thought that in case you don't take anything from my presentation, at least you'll definitely remember the right key answers to Slido questions. So can we switch to the next questions in Slido, which are the quiz questions? I think you have to put in your name with the idea that we know who the leaderboard will be. All right. Do we see the questions? Get ready, Lina. Okay. I'm ready, I think. Okay, so what is a supercomputer? Only wrong answer. No, there is one correct answer. All right, so there's 6 seconds left. 5, 4, 3, 2, 1. Okay, so the correct answer is a cluster of fast computers. I was actually thinking of using the answer as also correct, a very cool computer. I thought that could go as well. All right, can we go to the next question? So how are supercomputers useful for AI development? So to slow down AI models so they don't become too powerful too quickly. Supercomputers are only useful for video game graphics, not AI, really. Provide bigger memory and faster data processing for training models. All right, it's up. Yeah, correct answer. Good. Everyone knows everything. And the last question. Can we move on to the last question? So this is a level up question. For those who know everything, which country is home to the world's most powerful publicly known supercomputer in Europe? Okay. Almost. I know why you think it's Finland, but not anymore. So it's Italy. There was, I think, 2 years ago was still Finland. So fair enough, fair enough. I like the answer. So there's a couple of people who I know, and I saw from the comments as well about Lumi. So I think we should have a leaderboard afterwards as well. So I can see. Is there a leaderboard? No. Okay. Do you see a leaderboard? Yeah. Okay. Who's at the top? Okay. Well done. Thank you. Thank you. I have a small gift for you afterwards. That's why I want to know. Okay. So let's move on. All right, so I wanted to start with kind of going back 10 years. This is me in 2015. I'm not in any of these pictures, but this is on the bottom. That's my work in my bachelor's degree. I did computer science, and at the time we had modules in machine learning and AI. So what we did then is we kind of experimented with a lot of things, and it was a very new time, especially for AI, and it wasn't really understandable how we can use these topics. Really, it was cool, it sounded cool, but we kind of experimented with a lot of silly things. And one of the reasons was that we didn't have access to a lot of the tools in order to go a step forward. So we did these kind of like creative experimentations of trying to predict what would be, that's on the bottom was my experimentation of how to predict with kind of AI algorithms, how to predict what is aesthetically pleasing. So kind of creating different patterns that would be aesthetically pleasing for a person, and then they changed based on your inputs. Those are just like basic shapes at that point, and then I showed there's a couple of examples of my colleagues and students at the time. So they experimented. We also like similar things, trying to build kind of these visuals that are learning from experience and kind of growing around. And then at the top there was a guy who was sourcing data from Twitter at the time and trying to build this personality. So the Watson family that's kind of gathered from a specific person on Twitter, each of these Watson family members, and trying to build this personality based on the data that you can access publicly. To kind of say to people that your data is so public and we know so much that we can build a personality based on this. But what I wanted to say about this is that it's only 10 years ago. It seems like it's not really that much. But at the same time, we're at a stage where we're nowhere close to the developments where we are now. And one of the key aspects at that time that was growing was open source frameworks, especially for deep learning. And TensorFlow was one of them that was born, that kind of helped us to have access to open source tools and experiment with them. So further on, what were the key ingredients of how we really got to where we are? So one of the key ingredients, we now have a lot of data. So we had a lot of images, a lot of websites, a lot of text to use. Second thing, we have advances in training data. So these experimentations in TensorFlow or in other tools allowed us and allowed the society and anyone who's also a student, for example, to experiment, do something in their free time, upload it, open source it, and then someone else can reshuffle it. That means that each of us has, for example, even in a bachelor's degree, we don't have to start from point zero. We can use something that has already been built and build on top of that. So we're not starting from point zero, and that is a key aspect in here. Open source ecosystem is a key aspect as well. So if we get access to free tools that we can recycle, reuse, and then share with other people, we're advancing much faster. Cloud platforms, that is one of the key developments at that time that was growing, that also allowed us to access data, store data, and process it much faster. Transformers were the key aspect of the architecture behind GPT. Hardware challenge, Also, distributed computing allowed us, and it's also a key aspect of HPC, allowed us to get where we are. Memory, so faster memory, enabled handling larger models, and GPUs and TPUs. So obviously, the improvements in hardware here are the key aspect of how we got here. And this is a funny example. The same way as my phone camera at the time wasn't very good. I couldn't find a very good image of this from 2014 because apparently images were also not in that good quality. So this is the Gartner chart. Maybe some of you know it. So it's basically kind of the chart that's trying to assume what are the most popular technologies now and what's going to happen with them in the closest decade. So this is 2014. I wanted to do an example of when I was studying, basically. So these were the areas that were growing, and these were the areas, as you can see. So big data was assumed to be big in like 5 to 10 years. It is big now. It's the big thing. We really need specialists in this area, and this is the thing that has helped us to build these AI models. Data science, obviously, currently we see a lot of open vacancies and open job postings in data science, data engineering. We need data scientists to understand the data and help us process them better. The same way as quantum computing. It's only at the beginning. It's only starting to get cool and popular, and it's been such a long time, and I think it's still kind of like trying to be there, but people still don't know about it that much. But I'm trying to illustrate is what were the key things at that time, 10 years ago, that were going to be popular, and a lot of them were true. So a lot of them, because they developed, allowed us to get to where we are. And this is 2014, so I wanted to show a couple of things that are popular based on last year's predictions. So I don't have a 2025, that's why I used the 2024 and 14. So AI supercomputing, that's a word we know. So digital twins, that's one of the things that I want to showcase to you, and I'll talk about that a bit later. That's also a thing that you can see, okay, that's one of the things that is assumed to be popular in the next 10 years. So maybe we can make some assumptions that these are the fields that we could go into. Was there anything else that I wanted to out? Yeah. All right. So what changed in all of this period? As I said, so developments in training models and reinforcement learning. That's a key aspect. Developments in open source ecosystem frameworks allows us to get access to them. Anyone can get access to them. And people, even who are like amateurs in the area, can get access to experimentation and playing around with things. And it's very important for us to grow in this way. Developments in cloud computing and edge computing allows us to send these data and get access on how to do it. Developments in big data and access to big data to train the models. That's why big data is also popular. And developments in hardware, software, and networks, I put them in a big chunk to generalize a bit. Speed and memory access for processing data is here the key topic of why it matters. And this is where HPC comes in. So this is the key component of what, from all of these things that developed in the last 10 years, this is the small, as you would think, part that actually played a very, very big role. So what is HPC? So high performance computing. Some of you apparently have know about it or have heard about it. In a simple way, I'm trying to break it down as supercomputers plus smart software plus fast networks. And all of these three key ingredients are what makes high performance computing possible. And all of them are necessary. And each of these fields also require developments in these areas specifically. So what do all of these mean then? So let's break it down. Supercomputers. A supercomputer is a computer that's millions of times faster than a regular laptop, sometimes even more. So it makes things faster. It makes it possible for us to compute and process data in a much faster way. That is what allows us to build these AI models so that we can have access to do it faster. So that's in the hardware. Smart software, that's also a key ingredient. So without the software, we can't kind of deal with the hardware. So we need the software as well. So in simpler terms, it also is the key component of one of those three that breaks big problems into small pieces. But essentially, the software is how we can use all of this technology and allows us to operate with it. And we need advancements in this area as well. Fast networks. So I think there's a key thing that was missing here, but supercomputers have thousands of processors. They need to send results and data back and forth constantly. So if we're not doing it fast, we're losing time. So that's time that we could have used to process all of this data. So this part is also essential. So networks and network engineering is a key component. So we can't live without it in order for us to innovate in AI area. So, and this is a very generic slide. Yeah, everyone knows about it. So the market size in AI is growing. Duh, it's obvious. The same way, the growth of supercomputers is growing. But why is this even necessary? So yeah, we know about it. So what? It's the thing that I'm trying to say here is that it's intertwined. So we can't build the next AI innovations. We can't build the next tech innovations without the innovation and without the growth of high performance computing. So why is it important? It's important because that is what fuels this innovation. So HPC enables faster research and development. So it enables us to try out things, experiment with things, and especially for smaller companies, it gives the access to train their data and build technologies that are at the top of innovation. And this access to such tools is also a key component. So it also supports digital sovereignty. Sorry for the pronunciation. We need to invest in all of these supercomputers with the key aspect that we're at the forefront of it. So we have this technology and we don't have to depend on other countries, on other regions in order to build things and innovate. Because as we know with electricity and energy, in the future, that can result in things where this independence actually kind of deters our growth or makes us dependent on something else, on other countries. So it's also essential for competitiveness. So those who have the fastest technology and those who can get access to the fastest computers can also build the coolest technology because you get access to much faster process and to the most coolest thing. So this kind of also is intertwined. So no matter if you are in computer science or in AI, or you're actually in chemistry or in bioinformatics, this is where it matters. And more especially so, it matters in climate predictions. All right, so what are the areas of how HPC really makes a difference? AI and machine learning, something I've been saying throughout this presentation quite a lot. So how these supercomputers will influence AI and machine learning. So new AI solutions, providing tech and sovereignty to startups, training trillion parameter models, so we're getting a step up. Real-time adaptive AI, so scalable AI while preserving privacy. Climate and weather modeling. So this is already happening. Things like digital twins that allow us to recreate real-life simulations of what's happening in the world. That's a lot of data to process. But we can only do that with HPC. And in turn, that allows us to create these models, to predict what's happening, and then to make informed decisions of, hey, maybe we shouldn't do this, maybe we should do another thing instead. So climate risk modeling is a key essential thing that is already trying to take place. Medical research, so personalized medicine, that's also a lot of data that we need to process and we need to know how to process. Protein folding, molecular interaction and massive scale, digital twins of human organs or entire systems for testing treatments. So we wouldn't have to even test on people, we can test it on simulations, which is a big asset, and it's also saving a lot of money. Engineering and manufacturing, so simulation of materials, new materials, sustainable materials, vehicles, and infrastructure. So we can also create these digital twins of manufacturing companies and houses to understand the process and to predict if something's not working or is working. Finance and risk analysis. So all of these things matter in this development. So only with this advancements in HPC, we can build all of these things. So the further it's going to advance, the further we're going to have this opportunity. So I wanted to list and kind of showcase, this is for an example. So these are the top high-performance computing centers in the world. As you can see at the top, we have the top 4 are United States. And the 5th one, which was what you guessed in Italy, then Switzerland and Finland. And Finland has the closest one to, I think the closest one actually in distance. It's a good question. But yeah, and in Finland. So why does it matter? It's cool. We can use the United States versions, so we don't have to use ours, definitely. We can just leave them be, and then there are these centers, and they just exist. Well, it matters because if we have our own centers, if we have our own areas of where to test things, we can allow our own companies, researchers, scientists, and also small startups to test things and build things much faster. Also, our data and our privacy is our own. So we have the sovereignty of our own systems, of our own technology, and we can get easier access because we have the first hand. So in Italy, if we had something in our region, we have the first hand to use it. So anyone here with their company can apply to use it, and then you can train these models much faster. You're the person that can get access to that. And hardware and software advancements come with expertise and practice. So we need to develop these areas because very slowly we start in this way to build these scientists and experts around it. But scientists build other scientists and they support other experts. So we need these areas to be developed because those are the ones of how we can help each other and grow this. Otherwise, the innovation will stay in another place and we will be kind of backwards and not developing this innovation. So what's the next step for Europe specifically? What are we building? So we're building an exascale supercomputer in Germany called Jupiter. It's hopefully going to arrive this year, currently hoping and waiting when it's there. And this exascale computer is generally a very, very, really fast computer. But why it matters is that because of all of these centers that we already have, and all of this research and focus that we've put in as Europe into HPC and supercomputers, this will help us to be at the forefront in innovation. So we'll have the top centers and the top supercomputers across all of the continents. So Europe will be at the forefront, hopefully. If we are at the forefront, that also means that scientists from other countries, scientists from other regions, they want to work with us. That also means that the developments and the top of this innovation is with us. So we're at the top. And that, obviously, these kind of ecosystems of scientists and researchers and companies working together, that is going to build us as the top ones also in AI industry, because it's intertwined. So I wanted to further along with a quote that comes from Aileen Lee from Cowboy Ventures. She's accredited to come up with to the person who came up with the term unicorn when talking about startups. And a while ago, she was talking about how her investments have changed and how they're approaching things now. And one of the key things that she said that stayed in my mind was that the most promise is unsexy tech. So unsexy technologies that are niche technologies, but that critically fuel something else that we really, really need in this world. And supercomputers are definitely not sexy, which is why I think it's a really niche area, and it's a niche area where there is the future, and there is the promise of this area growing. So my proposal is that we do focus on the things that are really a bit complicated, the niche things, the engineering things, and the engineering fields. There's quite a lot of these fields where we really, really need development, where it's critical that we have this development. And without this development, we won't be able to get to the top of the innovation where we want to be. And we also won't be able to grow in the fields of such as AI and machine learning. So some of these fields would be sustainable battery and electronics manufacturing, in case anyone wants to go into that. Energy-efficient data centers, advanced sustainable cooling techniques and methods, because once we build the centers, such as, for example, a great example is Finland's Lumi, that is net zero carbon emissions. So it's fueled purely through renewable energy, and the excess heat they use to heat the city next to it, which is a wonderful example of how to work. So we need people who know this area, so who can help build these centers. So we need civic engineers, we need architects. We need high-speed sovereign cloud and data storage infrastructure. So cloud computing, also a thing, and edge computing to go into. Next level semiconductor design and fabrication. If anyone wants an idea of where to build a startup, definitely this one. Digital twin infrastructure simulation environments to model hardware and software interactions, data center scale, but also, as I mentioned, it goes into modeling, it goes into environmental modeling, it goes into manufacturing centers and so on. Medical and genomic data infrastructure. Across Europe, HPC training programs at all levels, so we need to train people in order to have these specialists who know how to work with these centers. So we have just a center, we don't have the people of how to do it. AI chips and AGIS processors, all of these things, and we need all of these things. So if you need an idea of what to work on, there's quite a lot we really, really need in order for this area to grow further. And where does my position stand and where does the RTU, so Riga Technical University High Performance Computing Center, also a mouthful, stand in all of this? So for us, we provide modern computing infrastructure to companies, students, and science institutions. Our goal is to provide the fastest possible that we can currently and also to grow with the industry in Europe. Work with scientists and companies and support them technically, but also support them in understanding how they can use HPC. So why do they need it and where it's beneficial? Because that in turn is beneficial to the region as a whole and to the innovation the companies in Latvia, for example, build or around it. We need to upskill experts, and that's something that we do in HPC. As I said, we need the people who work in the center, we need the people who grow this area, we need the people who understand where it's going and how to advance it further. So we need the people in this area as well. So we do seminars and training programs and interact with other universities to do the same. Also grow experts in the area of hardware and software necessary for HPC development. This is something that I mentioned in the previous slide as well. So we need these experts, and we need to help train them, and we need to help provide them opportunities. So also suggest other options where they can go and create these connections between other HPC centers, such as LUMI, such as in Italy, such as in Barcelona, and so on. So we need to work together, and that's something that we do consistently in order to get this message across. And provide that our companies and our researchers also get a place in working in these HP centers, which is a possibility. So if you want to be in the news in 10 years, I would suggest you choose some of these areas. Digital twin, infrastructure, bioinformatics, next generation semiconductors, environmental engineering, edge to cloud computing frameworks, embedded engineering, quantum computing. Any of these is something that is growing now, and if you remember the Gartner chart, that is those are the things that are going to be popular in the next 10 years. So as we see already now, there's quite a lot of vacancies, job postings, and opportunities for people who know how to work with the cloud. We need network engineers, embedded software engineers, and now we're at the critical point where we don't have them. We have a lot of vacancies, but we don't have them anymore. Not anymore, we just never had this kind of like push in the news that this is necessary. We had a push towards, we really need web developers, but that is kind of going towards the other way. So we really critically need these experts. So you have all of these areas where you can go into. Also, it's not always about engineering. So we need help in legislation, understanding how to use these and what we can do and what we cannot do so that we don't do the wrong thing in the long term. And we need innovation strategy. So we also need people who can see the big picture, who understand this technology, but help to understand how we can use it, communicate with companies, communicate with governments. That's not always about being an engineer. It's about understanding of what this technology is and why it's useful for you and who we need to contact in order for you to help this other person. So to finish off, if you want to be in the news in the next 10 years, go for unsexy technologies. I finished a bit early, but thank you, and more than welcome to contact me, to write me a message, to find me on LinkedIn, and communicate anything that you want, and I'm happy to collaborate, and yeah, write me a message. Thank you.